Let us get the equation for the average DC load voltage in case of full wave rectifier. Here we are considering the circuit of full wave rectifier, which is in the center type of configuration. Here we can see that we have two diodes, and this O point is indicating the center tapping of the winding. Let me quickly revise the working of this circuit. We know that whenever the AC supply is given, it will be consisting of positive and negative half cycles like this, and these are the waveforms which we are getting at the output, right? So here what we have during the positive half cycle, point A will be more positive as compared to point O, and our D1 will get forward bias. As a result, the current will flow in this direction, which is shown by these arrows. It will start from point A, then diode, then load resistor RL, and go back to point O. In this way the current is flowing through the resistor. When the negative half cycle arises, at this time B will become more positive as compared to A. This makes diode D1 reverse bias and D2 is forward biased. As a result, the current will start flowing from point B, diode D2, then load resistor and back to O. So we have seen that whatever may be the condition, even if it is a positive half cycle or a negative half cycle, we found the direction of current flowing through the load resistor is same, right? It means that's why we say that the output is converted from AC to DC, because it has flown from the in the same direction, right? Now here we are interested in getting the average value of this DC load voltage across the load resistor. So for before that we should be making very clear that what are these terms are actually meaning. So to save the time, I have already written this thing. Here what we are considering, VM is the maximum input AC voltage across each half of the secondary winding. Means here it will be VM, here also it will be VM. Only the thing is that this will be applied across one diode and this will be applied across the another diode. After that, RS is the resistance of the each of the secondary winding. Means this is RS and this is RS. That's why it is written winding resistance of each half of the secondary. After that, RF, you know, RF, this resistor will provide a resistance which is called as RF. This will also provide the same resistance we are assuming, that is RF. And RL, you know, that is nothing but the load resistance. So these are the things that we should be knowing before going for the average DC load voltage equation. Now with this assumptions or whatever the things we have discussed, what we can write the equation for the current IM. The equation for the current IM can be given like VM divided by RS plus RF plus RL, where what is the meaning of RF, RS and RL that I have explained here, right? So that can be the value of the current which we are getting through the circuit. Now the equation for EDC, that is the average DC load voltage, will be given like EDC is equal to IDC into RL. It is nothing but the equation like V is equal to I into R. So we have already seen what is the equation for the IDC earlier in the lecture. The equation for IDC, we have IDC in case of full wave rectifier, it is twice Im by pi. That's why what we can write, EDC is equal to, now this IDC I will put here, it is twice Im by pi, and it will be now multiplied by the resistance RL. Now here we can further put the value of Im in terms of Vm. So this equation we will put here, right? So that's why the equation for EDC we can write like it is twice, only I am putting the value of this Im here. That's why it is twice Vm by pi, and this resistances, it is nothing but a series resistance Rs plus Rf plus RL, and this whole thing will be multiplied by this resistance RL. So I can write RL here also. So this will be the equation for the average DC load voltage. Now we know that the RF, that is nothing but the resistance offered by the diode, and this is the resistance when the diode is in forward bias condition, so it is very small. In the same manner, this resistance RS is the resistance provided by the winding. It will be also small in comparison with the RL, and that's why what we can write RS plus RF. This is very small as compared to RL. So what we can do, we can neglect this term. So neglecting RS plus RF, we will get some equation which is now these two terms are neglected, and that's why we are getting twice Vm into RL upon pi. Now these two are neglected, that's why we are having RL. So this RL and RL can be cancelled, and what ultimately remaining is that EDC is equal to twice Vm by pi. So that is the equation that we will be using for average DC load voltage in case of the full wave rectifier.